Hello. Our topic today is ultrasound voice communication systems for the flight deck. Let's dive in. We are Creare. Founded in 1961, we provide industrial and government clients in the medical, aerospace, energy, defense, process, and manufacturing industries, with services ranging from applied research to prototype design to fabrication and testing. As an engineering services company, we are engaged in a wide variety of projects, including hardware design and prototyping, as well as the development of custom software solutions for specialized applications. Whether through licensing our technologies to prime contractors in select industries, spinning off completely new companies to introduce and sustain novel products directly to end users, or manufacturing highly sophisticated custom products in-house, Creare maintains a distinguished record of delivering our solutions to the marketplace. Hearing is critical to the warfighter. Hazards must be heard, identified, and localized, and voiced warnings and commands must be heard and acted upon. On the flight deck of an aircraft carrier, the extreme noise levels from nearby aircraft and other equipment make face-to-face voice communication especially challenging, if not impossible. The key reason that one's natural voice is inadequate on the flight deck is that the nearby aircraft are very noisy in the same frequency range as your voice. So, one mostly hears the aircraft noise rather than a person's voice. At ultrasonic frequencies, however, we have found that the aircraft generate far, far less noise. The UCOM system exploits this lack of competition and moves the talker's voice up to this relatively quiet area. The speech can then travel to the listener without being masked by the ambient aircraft noise. Once demodulated back down to audible frequencies, the listener can hear the speech. When it comes to conducting voice-to-voice communications in noisy environments, Creare's UCOM technology significantly outperforms conventional headsets with hear-through, a competing technology. During speech intelligibility tests, people using UCOM were able to understand over 75% of the words spoken to them, more than 3 times better than hear-through. This means a user can communicate effectively and naturally in loud environments without shouting or removing hearing protection. As depicted in this notice to all hands on board the USS Ronald Reagan stressing the importance of emissions control, or MCON, Navy and Marines operate with elevated MCON postures to reduce their RF signatures. Under elevated MCON, use of flight deck radios are not permitted, removing the primary communication path that provides voice comms in noise. Personnel must then fall back to alternative communication methods such as hand signals and messengers, which are often slower or less flexible than direct voice. As a result, flight deck operating tempo becomes harder to safely sustain. To help the crew communicate, we need a voice communication system that can cut through the noise of the flight deck while remaining MCON compatible. Ideally, such a system would provide both close-range voice comms for so-called face-to-face interactions and also address longer-range scenarios, such as across-deck comms, and for island-to-flight deck comms. Such a system would help sustain a robust operational tempo, despite the high ambient noise and an elevated MCON posture. Based on our current understanding of the Navy's communication needs, we envision a UCOM system composed of 3 types of devices. First, a helmet-worn UCOM. To serve the individual's need for communication in high noise, we will offer a helmet-worn UCOM package that will allow sailors and Marines to transmit and receive UCOM voice signals. By integrating directly with their helmet system, as opposed to a body-worn electronics unit, they will be minimally encumbered. Specifically, we intend to integrate UCOM capability into the HGU-99, exploiting our knowledge of the existing communications harness used in this safety helmet system. We expect that helmet-worn UCOM systems will enable direct face-to-face communication over distances of up to 60 feet. Our intent is to offer 2 variants, UCOM Basic and UCOM Plus, the latter of which allows for a hardwired connection to external communication systems, such as an aircraft's intercom or the shipboard sound-powered phone system. Second, the UCOM repeater node. To serve the need for across-deck voice communications, we will offer the UCOM repeater, which is a device that can be placed at selected locations around the deck edge to forward a UCOM transmission across the flight deck, if so desired. The repeater nodes will be connected to each other, either through the air via UCOM links or through shipboard infrastructure like the sound-powered phone system. By using your UCOM headset to speak to a repeater node, your voice will be emitted by all the other repeaters, extending communication reach across the flight deck. Finally, the UCOM projector. To replace the radios being used for communications from the island, we will offer the UCOM projector, which is a handheld or rail-mounted device for projecting UCOM voice from personnel in the ship's island down to personnel on the flight deck. Since UCOM is naturally directional, the bullhorn will direct its emissions toward the target individual without needlessly hailing the rest of the deck crew. As this shows, UCOM is a flexible architecture that can be adopted to many types of headsets and helmets, affording a wide range of applications for effective voice-to-voice communications in high-noise environments. There aren't many technologies that offer both face-to-face and moderate-distance communication in high-noise environments without emitting radio waves. UCOM is almost unique in this respect, and has no current deployed analog in the U.S. communications inventory. So-called near-field radio frequency technology, such as the 3M Peltor NIB system, does offer close-range communication, but this technology only supports a limited number of talkers, has a fixed broadcasting range, does not provide information as to the location of the talkers, and is not truly free of radio frequency emissions. As such, the UCOM system offers many competitive advantages that make it better suited for the target flight deck and other relevant markets. Creare's UCOM technology meets the DoW's need for a non-radio system that enables voice communication in noisy environments like the flight deck. Our UCOM system conveys a person's voice using ultrasonic sound waves instead of radio. Being an MCON-compliant voice communication system for high-noise environments, Creare is offering a unique product. Therefore, the primary goal of the overall program is to quickly transition UCOM to the U.S. Navy. We understand the market and the market players well. On the HGU 99 program, we teamed with Auto Engineering to first harden and productize, and now to manufacture the electrical wiring harnesses and communications interfaces for the system. At the end of Phase 2B, we will have a handful of UCOM prototypes and will have demonstrated their potential in operationally relevant environments. Additional investment will be necessary to mature, harden, productize, and fully qualify UCOM technology before it will be ready for introduction to the fleet. There's a clear market opportunity for a hardened device that provides better voice clarity than hear-through, especially when in noise. These markets encompass users that include other warfighters, security forces, and first responders, as well as construction, transportation, and heavy industry personnel. We know these other markets exist because the civilian variant of Creare's hearing protection helmet without UCOM has been successful with the national and international oil and gas industry. The success of our helmet with the industrial market provides us an excellent entry point for transitioning our UCOM system into the private sector. We thank you for your time and appreciate any inquiries about our UCOM product line. Our point of contact for this project is the lead engineer, Eric Desjardins.